Hi, this is the result of a rather active thought pause on whether to adopt a totally electric personal trowel. And I do this from Telford, which was announced as the birthplace of industry, a fossil fuel based one at that, but also one that formed the basis of the infrastructure for the developments in electric power. An important example of this now is the mobile electric energy as provided by lithium ion batteries. The chemical structures of the electrodes in lithium batteries have been compared to lasagna, but I favour today the French delicacy millefeuille, with its layers of puff pastry and cream, jam or fruit between the layers. The anode is of carbon in its graphite form, and when the battery is charged, there are lithium ions in between the layers. These are represented by strawberries in this cartoon. When the battery is in use, an electron flows out of the graphite through a circuit heading towards the cathode. The cathode is a much lower energy, and the prime example of a cathode is lithium cobaltate. The elegance of this chemistry and its applications was recognized by the award of the Nobel Prize for Chemistry in 2019. That was to John Goodenough, Stanley Whittingham, and Akita Yoshino. An important component was the lithium cobaltate cathode. John Goodenough was head of the Inorganic Chemistry Laboratory in Oxford in 1980 when this was first demonstrated. As the electron follows its path through the circuit, the positively charged anode loses a lithium cation. The red car is powered by the higher energy electron, and lithium cations will migrate to the cathode to offset the negative charge from the electron flowing to it. And so the graphite millefeuille loses a strawberry from the sandwich, and the cobalt oxide one gains a strawberry into its sandwich. The benefits of the battery over, say, the lead-acid battery were that it was lighter, it delivered a higher voltage for each cell, and this relatively easy structural change would be likely to be recyclable many more times. And indeed, the energy density of a lithium-ion battery is higher than its predecessors, and the smaller, lighter batteries give enormous benefits in mobile devices, from phones to cars. But there are concerns about the sustainability of these batteries. The estimated concentrations of the first 50 elements in the periodic table are shown here, and there are great variations. The highest concentration is observed for oxygen, one of the main components in the cathode. Lithium and cobalt are at intermediate concentrations in the region of 20 parts per million. And that's similar to the levels for nickel and copper. These are all more abundant than, say, silver or tin, elements that we have come across very often. However, the supply of cobalt is more restricted than that of copper, and the Democratic Republic of Congo, the DRC, is the main supplier. And there are serious concerns about some of the supply routes because they are exploitative. What is clear that the reclamation and recycling, the infrastructure that we need for this, must be stepped up fast. It's not sustainable to disperse these elements all around the globe, having spent so much time, effort and energy extracting them. Alternatives to cobaltates have been investigated. The Tesla Powerwall 2 is an energy storage device for solar generation, has less cobalt, with manganese and nickel also present in the mixed metal oxide host for the lithium ions. Manganese is rather more abundant than either cobalt or nickel. More recently, the lithium iron phosphate cathode has been manufactured and sold in devices. That's LiFePO4. Phosphorus is pretty abundant. That's similar to manganese, and iron is highly abundant. So these are a good factor as far as sustainability is concerned. So what does this do for my travel opportunities? For the e-bike, it means that I can charge the lithium-ion battery for the e-bike using an LiFePO4 battery from a relatively small power station. And that delivers a charge of about 100 watts. The bike battery stores 108 amp hours, which is within the 240 of this unit. The unit would fit into a pannier, and so in principle I can recharge the bike during a long trip with a visit or meal stop or a meeting, and so extend the range of the bike travel to about 30 miles or so. It also means that the charge being used can be solar generated. A sunny period delivers about 70 watts from this small portable panel. This makes this mode of travel seriously low in carbon use. That approach can extend to other devices like computers, tablets, phones, and also the strimmer, the electric drill, and the pump on the garden water feature. It might lead to a larger off-grid project in the future. That really seals the fate of having two internal combustion engine cars. Once we can get our ducks in a row, the e-bike option and one all-electric car seems to be the right combination to work for us, at least.